I wanted to do a quick video on your acceleration due to gravity lab just to make sure that everybody's on the same page, and because I know that I get a lot of the same types of questions as you're getting used to having these freeform labs that you need to set up. So remember, the whole reason that you're doing this lab is to confirm acceleration due to gravity. Right? That means that every single thing that you do in this lab should be to this one end. This is the reason that you're doing it. You want to confirm acceleration due to gravity. There's literally numerous ways. Like, I can't even count how many ways you can count acceleration due to gravity. And you're just choosing one of those ways to make it happen. In your background, which should be done right now, but if you wanted to go back and bolster it, beef it up a little bit, here are some of the things that I would be looking for. What is acceleration due to gravity? If you're going to confirm it, then you better know what it is. When is acceleration due to gravity experienced? Right? When do we actually accelerate with the acceleration caused by gravity? What are the limits of the lab that you are about to be doing? What does acceleration due to gravity cause? Right? So how does that affect the motion? What relationships are important? And this is where you would bring in any equations that are important, the relationships between position, velocity, and time, for example. And then any graphical analysis of acceleration due to gravity. What would an object experiencing acceleration due to gravity look like on position versus time, or velocity versus time, or even an acceleration due to time, or acceleration versus time gravity. Then you're going to come around to your procedure setup. Alright, make sure that you include a sketch of the material that you're going to use and how it's going to be used. That means draw it. How are you collecting your data? What does it look like? And what are the parameters? It should be a detailed sketch, including any measurements. And make sure you have a list of all the materials that you're going to use, because if you're going to describe using something, it better be included in that list. You want to describe how you're going to do what you're going to do step by step. What are you going to do first? Then what are you going to do? Then what are you going to do? How does the equipment give you the values that you plan to collect? Right? What data are you going to collect, and how is it collected? Right? If you're using the PhotoGate, how are you collecting data with the PhotoGate? What does the PhotoGate do as a result? What data will you be able to collect? If you're using video physics, what data are you going to collect, and how does that give you the values that you plan to record? How many trials are you going to do, and why are you doing that many trials, etc. And this brings us to the analysis. Right? Once you actually collect the data, you have to do an analysis. This is true every time. Alright, the first thing you should do as part of your analysis or manipulation of your data is actually calculate and confirm acceleration due to gravity. Alright, then you're going to compare that to the known acceleration due to gravity and determine what your error is and explain it. Right, here is a great opportunity for you to look at the consistency of your data, to look at how close to the true value it is. So you might want to calculate your percent error, and you want to explain, why does your data vary from the conceptual value of acceleration due to gravity? You need to come up with some reasonable explanations that explain, why is your data different? Is that okay? Does it mean that physics is wrong, or does it mean that there are limits in your data? Make sure that you discuss that. You have to decide to what points from your data you're going to plot. Right? That doesn't mean that you're just going to turn every single piece of data that you collected into a graph, but you do need to produce some sort of a graphical analysis. So you need to look at your data and say, what relationships is it most helpful for me to plot and show? Right? And then you're going to plot them. And then you're going to tell me, when you plot that data, what does it show? So once you've plotted your data that you collected, what does it show? How is it a useful piece of information? And finally, one of the primary things that your analysis needs to include is, to what extent did your lab succeed? And you need to give me a reasonable explanation of how well your lab was designed and how well it actually met the goal that you set out to accomplish. That kind of does it. I do recommend that you go back and you take a look at this again and again as you put your lab together. You have Friday to do this, and that's it.